Bismillahirrahmanirrahim. This is Aisha Nazir. The topic of today's lecture is type of instructions. In the previous lecture, we see different types of ISA architectures. In this lecture, we will discuss different types of instructions, that what type of instructions we can give to processor to perform the operations. So let's get started. Features that need to be focused while designing an instruction set are what type of instruction we have to give to the system, means what type of operations ISA has to perform. There are different types of instructions, like the first one is data transfer instructions. That transfers data instructions between the registers and memory and IOs. There are two data transfer operations. First one is load and the second one is store. The load function loads a copy of data from memory to processor to perform the operation, while store that saves data from processor to memory. So the first one is data transfer instructions. After that, the second one is data manipulation instruction. The data manipulation instruction, basically these instructions perform the arithmetic or logical operations. Mathematical operations like addition, subtraction, multiplication, increment, etc. While the logical operations are AND, OR, XOR, etc. Along with, we can also perform the shift operations that are basically used to perform the bitwise shifting. The third type of instruction is program sequencing and control structure. We know that usually the program flows in a sequence, all instructions executed one after the other, but we can interrupt, we can make change the sequence of the execution of the commands. Instructions are executed in sequential manner one after other. So to change the order of execution, we use such instructions like loops, ifs, and jump with the jump operations with program counter. After that, the fourth one instructions, that is mainly the part of data transfer instruction, is the IO instruction set. That is basically used to transfer data from register to memory locations and to different IO devices. The length of instruction is basically depend on number of operands. As more operands will result in long instructions. Instruction is basically an amalgamate of three things. Number one is addressing mode. Addressing mode means at which place in memory or in the register operands are saved. Second one is opcode, which operation has to perform. This is defined by the opcode. And operands are data on which operation has to be performed. For example, if we want to perform addition like A plus B, then A and B are the operands that will save at some memory location in the registers or in the memory according to the instruction architecture, right? So these operands will save on some memory location that will save on addressing mode. While the addition A plus B, the plus sign is basically defines that we have to perform the operation. So that will save in opcode. The operands, the opcode, and the location of the operands. All these three things makes the instruction, makes an ISA. Let's understand it with a simple example, that how we simply add three words and how we can perform addition in assembly language and how we can use the loop in assembly language. So example is that we are adding three numbers. So the sequence would be move data 1. R0. R0 is basically the register 0, while the data 1 and data 2 are the values of A and B. For example, A is equal to 10 and B is equal to 20. So A would be, the 10 is the data 1 and the 20 value is the data 2. So in assembly language, the address of memory location of numbers are referred as data 1, while R0 is register where data is moved to perform operation. It means that in register 0 we are moving the value, we are moving the memory location of numbers in R0. In the same way, add data to R0, add operation performed with data 2, that will perform addition with content of R0 register, which already saves the value 10. R0 has the value 10 while the data 2 has the value 20. So the add operation will perform with the content of R0 which has the 10. So 10 plus 20 will be added. Add data 3 R0 in the same way. The third value will be added to R0. Then after that, move R0 sum. It moves results of addition that are saved in R0 to memory location sum. So in this way, in assembly language, all the instructions will be executed in a sequence manner. Instead of using add instruction again and again, we can use jump or loop instructions that will shorten the code. How we will shorten the code? Let's see. Move L. L is basically list of numbers, the 3 values, to register 1. So move list of numbers to register 1 register that act as counter. That will tell that how many times the loop executed. And we clear the register 0, clear all the content in register 0 register. And then we start the loop body and we say decrement register 1. Decrement elements from register 1 register at each iteration. Means register 1, for example, register 1 has 3 values. So each iteration it will decremented 1 value. Branch greater than 0, then loop. Conditional branch is until register 1 content has value, means greater than 0. Loop will iterate, means it will move content from register 1 to register 0 and adds. And after that, move register 0 to sum. When condition fails, then there is no element in register 1. Then register 0 that contains sum of all numbers will move to the output location, that is sum. In this way, we shorten the lengthy sequential instructions into a very short code. So in short, move and load are basically the data transfer or IO instructions. Loop and if are basically is program sequencing and control instruction. While performing addition and subtraction and different type of logical operations are basically data manipulation instructions. So hopefully you understand different types of instructions that we use to perform operations on data. Thank you very much.